Hey guys, welcome back to our video lecture series of geotechnical engineering. Today we are discussing about the phase diagram of soil and some basic physical properties of the soil. So let's start with the phase diagram. Here you can see in the image, this is the three-phase system of the soil, and you are watching here soil sample. Okay, in this soil sample, there are three main contents like soil solids, moisture, and air voids. The combination of three these phase a soil sample could be made, right? Here is the material component. S denote sand or solid particles, A denotes air voids, and this dot is for moisture content, which is denoted by W. Here, to understand this, we can make some figure like this three-phase system, in which here is a soil solids. This portion is considered as a soil solids. Other layer is of available moisture content in that soil sample, and last one is air voids, right? We can combine it and differentiate with the different phases like soil, water, and head. Let's consider it in dividing two portions like volumetric and another one is weight portion, right? So this soil sample, soil mass has a considered as ms, and the volume considered for the soil is vs. For the water content, the mass is considered as a mw, and the volume is considered as a vw. Same for the air content, the mass considered as ma, and the volume considered as va. Here we know that weight of air is equal to 0 because we are living in same atmospheric pressure here. So on all the material it will be same, so we consider it as a 0. But we know that air content can be measured throughout the volume, so it is denoted by Va. Here air content and water content is considered as a volume of voids. Why? Because in the soil mass it will be stored in the voids, either it is air or water, so we can consider it as a VV. So total volume is considered as a VT, V for volume and T for total, so it is total volume. Similarly, we discuss about it that mass of air is going to be 0, right? And so that the ms and mw is considered as a total mass. Okay, mass of soil and mass of water is considered as a total mass because ma is equal to 0. Next, see here three-phase diagram. Okay, so it will seen like this. You can see here soil solids, there are too many air voids. In some voids it filled with water and another are from air content. Clear? Now in some case there are two-phase system too. Let's see the figure and can understand. See, if the sample of soil is totally saturated means all white particles are covered with the water. Okay, I'm talking here about 100% saturation. So it will become submerged. If your soil solids are submerged, submerged means it is totally below the water. As you know that submarine is a vehicle which can transfer through the sea, right? It is totally into the water. So here is not saturated, it is a submerged soil. Okay. How it can be seen in the soil sample? The soil solids are totally covered with the water. Water is indicated in blue color, right? On other hand, if this soil sample will be oven dried, right? Because when we are taking a sample from the natural ground, after that we are going to oven dry it, right? So we will know the moisture content of natural soil. So here is the sample. If it will be oven dried, then it will seems like this, nothing, right? Only soil solids, and the voids are totally covered air voids. Hope you guys understand about three phase and two phase. So now let's understand about phase diagram. For the purpose of study and analysis, it is convenient to present the soil by phase diagram system, with part of the diagram representing the solid particles, a part representing water or liquid, and another part air or other gas, as we discussed earlier. So from the first figure, we can understand about volumetric and weight proportion of the soil. Similarly here, Wt is a total weight, Ws is weight of solids, Ww is considered as weight of water, and Wa is considered as weight of air, which is equal to 0. Similarly manner, Vt is considered as total volume. This Vs is a volume of solids. This here Vw is volume of water from here to here, and Vv is a total volume of voids. So which is considered as a Va and Vw. Va is a volume of air plus Vw is equal to Vv, total volume of voids. Here I differentiate some equation with the volumetric ratio, weight ratio, and unit weight ratio. So let's understand about volumetric ratio. Here are some property based on the three-phase system. First one is void ratio. Void ratio is denoted by small e. Okay. So the void ratio is the ratio of volume of solids to the volume of solid. Volume of voids, which is denoted by VV. Okay, VV is equal to VA plus VW. VA is volume of air, VW is volume of water. So the equation of void ratio is E is equal to VV upon VS. The another equation is porosity. Porosity is denoted by N, small n. The porosity is equal to, and the porosity is the ratio of volume of voids to the total volume of soil sample. So basic difference is between void ratio and porosity. In void ratio, we can take Vv upon Vs, and in porosity we can take Vv upon Vt. Vt is equal to total volume of soil into 100. Here we can take percentage, that's why multiplying with the 100. In all geotechnical engineering equations, we can take void ratio. Okay, because we in geotechnical engineering or soil mechanics or foundation engineering, we have to deal with the soil solids. So that here we are going to take void ratio with all the equation. You can see in an next lectures about index property of soil. You can see everywhere a void ratio only, not a porosity. Okay, because in the porosity it is a total volume. In total volume there is a volume of solid, volume of water and volume of air. But for the functional use in this geotechnical engineering, either runs soil mechanics, we have to deal with the soil solids only, because total strength of the soil sample is only because of soil solids. That's why we are going to take void ratio instead of porosity. The third one is degree of saturation. Degree of saturation is denoted by SR. The value of SR is lies between 0 to 100%. If the degree of saturation is considered as 0, then the soil sample is dry, and the degree of saturation is considered as 100%, then it is considered as 100% saturated sample. So the degree of saturation is the ratio of total volume of voids contains water to total volume of voids. Okay, so the equation will become S is equal to VW upon VV. Okay, here we are going to take percentage, that's why multiply by 100. Here VW is volume of water and the VV is total volume of voids, which can contain volume of water plus volume of air. Next, weight ratio. In weight ratio, we can take these sides of three-phase system. A water content is a weight ratio for water content is denoted by W. So water content is the ratio of weight of water upon weight of soil solids. Here we are going to take only soil solids. So we can consider a soil sample. Okay. After we are going to override it and take the weight of the soil sample. Already we have taken a soil sample in natural condition. After deduction, the natural condition and over dry condition, we can get the water content. So here you can see the water content equation is W is equal to weight of water upon weight of solid into 100. The next, unit weight ratio. In unit weight ratio, I divide it in 4 equations. First one is dry unit weight. A dry unit weight is denoted by gamma D. So the gamma D is equal to the ratio of weight of soil solids upon total volume of soil. We already know that the density as equation is weight by volume or mass over volume. So here the dry density is Ws upon Vt, weight of soil solids upon volume, total volume of soil sample. The another equation is bulk unit weight. Bulk unit weight is nothing but total weight of soil sample divided by total volume of soil sample. So the equation will become for the bulk density is Ws plus WW divided by Vt. Here we can take Ws plus WW and not taken as WA, because we know that the weight of air is become 0 for this three-phase system. So if you put the total weight of soil sample is equal to WA plus WW plus WS, then submit the value of WA is equal to 0. So it will become WS plus WW upon VT, total volume of soil. Then saturated unit weight. Consider S is equal to 100% and the volume of air is equal to 0. As we know, a saturated two-phase system or submerged two-phase system diagram. Gamma saturated is the ratio of weight of soil solids plus water divided by total volume of soil. So weight of soil solid plus water is considered as Ws plus WW divided by Vt. Then fourth one is submerged unit weight. Submerged unit weight is denoted by gamma dash. The gamma dash is the value of gamma saturation minus gamma W. Here submerged means the soil sample is below the water table in a natural condition. Here gamma saturation will be taken as from the equation of gamma saturation and minus gamma W, which is the value of density of water. We know that the density of water is 1 gram per cc or 10 kilonewton per meter cube. Here take a note, the density or a unit weight are the ratio which connects the volumetric side of the phase diagram with the mass or weight side. Next, specific gravity of soil. The ratio of the weight of solid particles to the weight of an equal volume of distilled water at the 4 degree. So, the specific gravity is denoted by Gs, S in a subscript. Capital G is denoted by, is a notation of specific gravity. The equation of specific gravity is weight of solid upon volume of solid into gamma W of that material to the unit weight of water at 4 degree centigrade. The specific gravity of a certain material is a ratio of the unit weight. Why? The specific gravity of solid is often needed for various calculations in soil mechanics. Here I told you that the specific gravity of certain material is a ratio of the unit weight. So from this equation, G is equal to Ws upon Vs into gamma W. We know that the weight of solid upon volume of solid is nothing but a density of solid. So it is denoted by gamma S. So the equation will become for specific gravity is G is equal to gamma S upon gamma W. Density of solid upon density of water. Density of water is 1 gram per cc. Here there are two values to determine the specific gravity. The GW, with specific gravity of water, is 1 and the specific gravity of mercury is 13.6. These two values are given to determine other value of the soil. So let's take a look of the expected value of specific gravity for different type of soil. Here I give the type of soil sand. The specific gravity lies between 2.65 to 2.67. For the silty sand, the value lies between 2.67 to 2.7. For inorganic clay, the value of specific gravity lies between 2.7 to 2.8. For the soils with mica or iron, it's a mineral. Mica is a mineral of soil. The specific gravity lies between 2.75 to 3, and the specific gravity for the organic soil, it will be greater than 2. So these are the expected value of specific gravity. Today we complete our lecture to here. Thank you for listening. See you in the next lecture.